In this problem, we're asked to find dr d theta, that is the derivative of r with respect to theta, when r equals the tangent of theta times the secant of theta. So first of all, looking over the problem, tangent theta, secant theta, we see we have two functions right next to each other, and we know that means multiplication. So we need to use the product rule in order to find this derivative. So our first function is the tangent of theta, and our second function is the secant of theta. So from there we can find each of their derivatives. So the first function's derivative of tangent, is secant squared theta. And the derivative of secant theta is secant theta tan theta. Now once we have all the parts in front of us, we're ready to put it together and find dr d theta. That is, again, the derivative of r with respect to theta. So we start by taking the second function, secant of theta, and multiply it by the first function's derivative, secant squared of theta. So that gives us secant theta times secant squared theta. And since this is product rule, we add, and now we come the other way. We're going to start with the derivative of the second function and multiply it by the first function. So that's secant theta tan theta for the derivative of the second function times, that's supposed to be times, tangent theta, which is the first function. So cleaning this up a bit, with our first term we have secant times secant squared, so that will give us secant to the third of theta, plus, with the second one we have one secant and two tangents, so that gives us secant theta times tangent squared of theta. Now the rest is actually the cleanup, and you can go in many directions in this problem. First thing I notice is there's a common factor of one secant theta. So we'll start by taking that out and see what's left. So secant theta comes out. That'll leave us with a secant squared. The 3 power, take out 1, leaves us with 2. Plus, in the second term, we have secant theta, just one of them, so we're just left with the tangent squared theta. Now when I look at this, the remaining factor there, secant squared plus tangent squared, I immediately think of Pythagorean identities because I see the squares, also the fact that the Pythagorean identity, tangent squared plus 1 equals secant squared. So I could make a replacement there and combine some of those like terms. Or I could actually go to sines and cosines and see where that will take me with this one. So we'll start by replacing, let's see, the secant theta with 1 over cosine theta, and our secant squared as 1 over cosine squared theta, plus tangent squared is sine squared theta over cosine squared theta. And what we notice is there's a common denominator here in the two fractions inside the grouping symbol. So we can then rewrite them with a common denominator. And let's see what that will get us. So we've got 1 over cosine theta on the outside, and putting this over a common denominator of cosine squared theta, we have 1 plus sine squared theta. And now one more thing we can do is we have a cosine theta in the denominator on the outside and a cosine squared in the denominator on the inside. So we can condense them just a little bit and make that be 1 over cosine to the third theta times 1 plus sine squared theta. And then finally our last step is to convert the 1 over cosine cubed back to the reciprocal function of secant. So secant cubed theta times 1 plus sine squared theta.